Okay, guys, so polynomials of higher degree. Let's quickly go through the things that we discovered today in our investigation. First thing was the number of zeros a polynomial, and the important word here is could have, and that's at a maximum. Okay, so the most zeros it could have is equal to the degree. And so what we'll look at later this week when we get into doing some more of this focus on finding zeros of polynomials is we're going to come up with some methods of not only determining exactly how many a particular polynomial has, but what they are. Okay. But for now, just in general, we know that they can't ever get any larger than the degree. Okay. Likewise, the number of extrema a polynomial could have at a maximum is equal to the degree minus 1. It was always 1 less. So like parabolas have 1 max or min, cubics could have up to 2, quartics could have up to 3. That was all that stuff we talked about on the first page. Okay, end behavior was another thing we investigated today. So basically, I'm going to put this into two groups. So if we have even powers, or even degree, I'm sorry, and odd degree. Okay, so even degree, we could have, and again, there could be something happening in the middle of the function, but at least the end of the function could be doing that, or it could be doing that. So either they're both going down, they're both approaching negative infinity, or they're both going up, they're both approaching infinity. And for them both going down, that's if the leading coefficient a sub n was less than 0. And down here, this would be if the leading coefficient a sub n were greater than 0. So even degrees, the end behavior always goes the same way for both. Either they're both down or they're both up. The odd degree, okay, so if the leading coefficient is negative and it has an odd degree, is it going to be the first one's down, the second one's up, or the first one's up, the second one's down? Yeah, so this one, the left end behavior would go up and the right end behavior would go down. And again, there could be all kinds of whatever going on in the middle, but it's going to start heading up with going to negative infinity and going down as you head out to positive infinity. Or it's the other way around for the coefficient being positive, then it's down and then up. Okay, I think that's probably the easiest way to summarize that, is to just think of it that way. Okay, again, this is another example of if you can visualize in your head what's going on, then you can write down those properties of your functions, what's happening pretty easily. Okay, so I think the visual there is helpful. Okay, so there's that as far as the polynomial theory is concerned. The other thing we talked about with end behavior was that you really only need to look at the first term, and we kind of showed that when we were looking through at those graphs. So just so you don't get bogged down, for long polynomials, just investigate the first term. Or the leading term, I guess, technically is what it's called. all of that stuff is there. The leading coefficient being positive or negative, the degree, whatever that is, it's all there. Okay. So we're going to analyze, just as an example here, another polynomial. And we're going to try and do all of this stuff all at the same time. And we're also going to do a little bit of looking for some zeros here too. So let's investigate x to the third minus x squared minus 6x. And we're going to see if we can figure out all this stuff we just talked about. Additionally, we're going to look and see if we can find its zeros too, which this one we can. There are some that we can't at this point, and there's some that we can. This one we can. Okay, so first thing, let's figure out the end behavior of this. So there are two limits that we have to calculate. And in general, I want you guys writing out the whole limit as x goes to infinity and all of that in the future. In that worksheet, I had you skip it just because it got tedious. But if I do ask you for end behavior in homework, I just, request that you still do that with this. So for this particular function, looking at what we've got there in that leading term, what is the limit of f of x as x goes to infinity on this one? Infinity. Positive coefficient, odd degree, this is going to be infinity. Okay, so additionally, what is the limit as x goes to negative infinity? So that would be negative infinity, right. Yep, it's an odd degree, so those are going to be opposites. If one's positive, the other one is negative. And since it's a polynomial, the end behavior of a polynomial is always positive or negative infinity. It's one of those two things, right? That's what we looked at. Other functions we've studied, I don't want you guys to forget about this, but other functions that we've studied won't necessarily always come out to positive or negative infinity. Those could be like 0 or 2 or all kinds of different stuff too. But it's just in this polynomial investigation stuff that we're looking at, those types of functions are always just those two. One of the two of them. Okay? Okay, good. So we got the end behavior. So let's investigate the zeros real quick. Now we can talk a little bit about what's the maximum number of zeros it could have, and what's the maximum number of extrema it could have. But in this one, we're going to go a little step further. We're actually going to figure them out. Okay? But for now, though, let's just answer those two questions real quick. How many zeros could it have? 3. And how many extrema could it have? 2. Okay? So we know we could have up to 3 zeros. Let's see how many of those we can actually find. So this particular function, the reason that we can actually get into this one is that we can factor this. Okay? Now, I'm not sure if you guys have ever factored anything that is larger than a quadratic, if it's a polynomial like this. But this particular one is accessible to you guys right now because it has a GCF. What is the GCF of those 3 terms in that polynomial? X. So if we take an x out first, then what we're left with, x squared minus x minus 6, is something that you can further factor. Okay, that's a quadratic that you guys can factor. What two numbers add to -1 but multiply to -6? -3 and 2. Okay? So if I factor that polynomial, and don't forget the x here still, because I still took out that x, it's got to be there. But now I've got this thing fully factored. X times x minus 3 times x plus 2. Okay? And if I want to find the zeros, remember, I'm curious about where is that equal to 0. So if my 3 factors are x, x minus 3, and x plus 2, what are my 3 zeros then? You got it. X equals 0, x equals 3, x equals -2. So we're actually able to find them. So the maximum number of zeros it could have is 3, and lo and behold, it actually does have 3 on this one. Okay. Now the extrema, we don't have like a by hand method for doing it until you get to AP Calculus, then we can do it using derivatives, but for now, we're kind of stuck there. So we can't really answer that question anymore without looking at the graph on the calculator. But this is some stuff at least we can do at this point. So, all right, I'm going to call it good, and I'm going to let you guys get to work on this assignment. We got a little bit of time, not a ton, but some, that you guys can get started.